As I mentioned last time, today we're going to talk about the statistics, and then with the following 2 weeks, we also talk about the statistics. So I talked with her. So next week we also cover some part of statistics, and after then we will have an Easter break. After then we will have a project week, and then we will have a last statistics session. Okay. And then today I'm going to talk about analyzing the data with statistics. I will not talk about the math side, but I want to introduce some math, statistics tool for your research. So this is my focus for this class. So statistics, because census is quite expensive, and then sometimes that is an idea, but actually is impossible actually. So for the region, from the population, there is the red dots represent all the population from the data. And then sometimes it is hard to check it out everything. So we select some samples from the population that whatever you use a random selection or stratified selection or cluster selection, we can select some data. And then from the data, we wanted to see something, what is the characteristic of the data. So I'm going to talk about the descriptive statistics first. After then, I'm going to talk about the inferential statistics. So what is the inferential statistics then? Have you any idea? Literally, the inferential means, so we can infer the characteristic of the whole population from the analyzing the given sample data. So we're going to talk about this one next week. So today I'm going to focus on the descriptive statistics first. So as I mentioned before, the descriptive statistics just to show some central tendency of the samples, which is mean value, median value, and a mode. And it just summarizes the characteristic of the sample. On the other hand, inferential statistics handle, it makes the inferences, or we could say that it's a prediction about the characteristic of the larger population based on the given sample data. So last time I gave you assignment, and then maybe when you read the paper, you have seen this kind of expression. So interface A takes more times than interface B to complete the task, which p-value has a 0.3 or 0.5, whatever, right? So this type of representation comes from the inferential statistics. So there is some options you can use this kind of statistics tools. There is some software, SPSS, SAS, MATLAB, or Minitab. These are off the shelf, so you can easily use this stuff. But actually, there is a cost, so you have to make some payment. And then spreadsheet like Microsoft Excel. Maybe at just the beginning we could use this kind of tool, but actually that does not support more strong functions, or it is sometimes hard to manage your data. So I don't recommend to use this one, but we still could use this spreadsheet as well. And the other option is you can also use a programming API like R or Python. So maybe you need to learn a little bit more about how you can handle this programming language. But there is the most advantage is that it is free, so you can freely download from the website, and then it is much easier to handle the data set. So normally after you conducted your study, then maybe you will get your data with a CSV format, which is a comma separated version, which is the most simplest one. But sometimes you may need to reconstruct your data format some other way. In this case, if you use a programming language kind of R or Python, then that is much efficient to control each data set. So have you any experience to use this kind of tool or API before? Okay, so SPSS, SAS, MATLAB, Minitab, maybe Excel, right? Yeah, Excel, yeah, okay. And then R or Python, okay, which one? Python, great, okay. So I would recommend you to try something with R or Python because those are free. And then also SPSS and then MATLAB Minitab, you can access it with a trial version as well. So that will help you to understand how you can handle those data. At the end, actually, you will control all the data. You have to analyze your own data from your research. So this is really helpful. But the problem is if you think about it, okay, I will learn these guys when I'm doing my research topic, when I'm doing my own research, then I would say that is too late because during the time you will be very busy. So there's no time to run something else. So I really recommend you to check it out, these guys. And then I also believe that mechanical guys also required to analyze the data, right? So even though you don't have much experience regarding programming language or software, the statistics packages, just try them at this moment. That is much better. And then actually that is related to our assignment for today. So, all right. I just want to talk about preparing the data set because the analyzing the data is a next step after we collect some data. So if we collect the data in a wrong way, then actually your analyzation will have no meaning. So collecting data is very important. Recently, I also running some study, and then I also had some mistake. One participant had a double answer regarding some questionnaire. So I just found that error, so I just removed it. But this will happen, I think this will happen to your experiment. It could be. So you have to, before you analyze your data, first thing is you have to clean up your data first. After that, so you should detect some error. If some numbers come from in a wrong way, then you have to find it and remove it first. And then also think about the format. Format is quite important because when computer work on the data analyzing, like t-test or ANOVA or MANOVA, whatever, that is very sensitive with the format. Computer is not super genius. It's just sometimes it looks like a very dumb. So you have to care how you organize your data format. And the last one is coding. Okay. Also, I want to remind you the type of scale of measurement. Last time we talked about nominal data and the ordinal data, interval data, and the ratio data. And then nominal data is a discrete way, and the ratio is a continuous way. So this is just a simple quiz. So pointing error in millimeters. What is the type of the scale of this one? Okay, let's come back to here again. So what is a nominal? If we provide some gender or some grade, this kind of thing is a nominal data because there is no way to convert with a number, right? And what is the ordinal? That is related to each order. So 1, 2, 3, 4, 5, I allocated this number by each order, right? So this kind of thing is ordinal. And what is the interval? If between each scale, if we can add or subtract, then it has some gap, which is an interval. So that is an interval type. And what is a ratio? Ratio is a much wide number, like a real number or integer number, whatever. So when we measure our weight, height, distance, or some completion time, age, this kind of thing, we could say that it's a ratio. So let's come back to here again. Then pointing error in millimeters. What is that? Ratio, great. And the number of times user made mistake. Ordinal? Any other idea? Yes, we can say that it's ordinal, but also we could say this is an interval. So that is a very interesting thing. So, okay, and the system usability scale. What is that? Ordinal, right? Because maybe we could provide some questionnaire. So how much did you like the device? Then maybe 1, 2, 3, 4, 5, 6, something is like that. And then 1 mean not so much and very much, something like that. And then computer expertise in years of use. Interval? It could be, yeah. Yeah, right. So actually, that is actually he mentioned well. That is depend on how we could construct the questionnaire, construct the scale. So it could be interval, but I would say that is ordinal, right? And the last one, computer expertise in 3 levels. Yeah, ordinal. And then maybe depending on the structure, it could be also be interval. Okay, let's talk about the descriptive statistics. So I'm going to talk about the univariated one first, which means it handles only one variables in the data. So the data set are related to only one variable. There is only one factor. So we should think about the number of samples and then the distribution of samples, which is, I'm going to talk about the central tendency and the dispersion and the frequency of the distribution. As I mentioned before, census is expensive. So for the region, we randomly or stratified or cluster selection method, we selected some samples from the population. So the number is very important. So size of a sample is very important. More number of samples will have a more stronger statistics. That is true. So the effect size of the data is important, which I will talk about it later, 2 weeks later. So we will handle the power analysis, which is make a decision regarding the number of samples for certain study. So, for example, when you are preparing your study, then maybe you could think, okay, for this study, I will have a 10 participant. I'm not sure it is enough or like, or okay, so for this study, I will have a 100 participant for my study. I'm not sure that is enough number or efficient number or not. So the power analysis will give us some suggestion regarding the number of samples for your study. So I'm going to talk about that one 2 weeks later. Okay, so the descriptive statistics is relatively simple and very basic, but I'm not sure why some people forget to report the result in their paper. Maybe that is too simple, but that is a very important one. It still gives us some characteristic of the given sample data. So do not forget to report the descriptive data, descriptive result in your paper. Okay, let's think about it. What is a central tendency? This is a very simple one. We know already. The central tendency means a value that characterize the middle list of a distribution. So we could represent the middle list with a mean and a median and a mode. So as you know, mean is just an arithmetic average. So sum every data and it divides the number of data. That is a mean. And what is a median? That is just located in the middle, which is a 50% percentile of the data set. So that is a mean. So we can find the median from the ordinal or interval or ratio scale. And what is a mode? Do you familiar with the term of the mode? Yeah, right. So that is actually basically that is just a frequency. So how many times certain data sets show up in the data set? So we could use the mode in the nominal, ordinal, and the interval and the ratio scales. So this is just a simple example. So elementary school students can solve this problem. So there's some data set 6, 2, 5, 1, 2, 9, 3, 6, 2. So the mean is the sum everything and divides the number of data set, which is 4. Good. And then we could relocate each numbers by each order, and the 3 is exactly located in the middle in the data, right? And what is a mode? The number 2 is the most frequently showed up in this data. So when we say what is a mode, then we could say that is a 2. Okay. So when you represent the data with this kind of a bar chart or histogram, then the peak always indicates the mode, because the peaks represent each frequency, right? The highest frequency. So when we report the descriptive statistics, especially when you focus on the central tendency, then this is a quite good chart. When you have a nominal variables, then mode you can use a mode to represent the result. And when you have an ordinal one, the median could be the best one, and the interval ratio one, then you could represent with a mean value, and the interval ratio one, then you could also represent with a mean with a median. Because it says that is a skewed. I'm going to talk about this a little bit later, but skew is how much our data set moved to left side or right side. So I'm going to talk about this one. For the region, actually I'm going to talk about that one again, but we could represent the data set with this type of distribution. So let's say this is a normal distribution. If we have a normal distribution, then let's say this is just a peak, then what does it mean here? Because that is a peak, so it means that is a mode, right? Okay, so this is a normal distribution. The characteristic of the normal distribution is a mode and then median and mean always has the same value. always located at the same place. But if this graph, if this distribution skewed like this way, then always here is a mode, right? Whatever is skewed this side, this is a still mode. But median and mean will be differ, right? Okay, I'm going to talk about this some more. So another one is a frequency. So how many times certain data show up in my data set, which is a very interesting one, right? So we haven't seen this type of a chart, which is a pie chart. So using the pie chart, we can represent how many times which item showed up during this data set, during this population. So maybe we could use an integer number like 4, 5, 6, 1, 4, or we could use like a relative frequency with a percentile. So 20%, 25%, 30%, 5%, and 20%. So we could represent the nominal scale with this pie chart, and the other way is using the bar chart. The bar chart can be used with a nominal or ordinal data set. So as you see here, there's 5 items here. So single, married, and widowed, divorced, separated. And then when you use a bar chart, you should be careful how you can set the y-axis. Even though this data set and these two represent same result, but because the user set different value of the y-axis, the y-scale, so it seems like a very different. If I see here, then it seems like the male side has a much higher, but when I see this graph, male and the female seems like it doesn't have a much difference. That is skewed participant perception. I mean, reader's perception. So that is the wrong way. So not so good. So when you use a bar chart, you have to consider how will you set up the axis, the x-axis and the y-axis. Okay. Also, when we use interval or ratio data, then we also represent its frequency with a histogram. So each histogram also represents a certain range. So each being represents each frequency here. Then maybe you might notice that this histogram and then this bar chart seems like a very similar, right? Then what is the difference? This one and this one. How do you think? Did you find any difference from even from the graph or from the shape or something meaning? This one and this one.
Are they touching each other?
Yeah.
Spaced.
Right. Why do you think? Sorry?
Calculate the length is calculated.
Yes, but actually she mentioned there is this bar chart has a gap between each items, right? But this one, doesn't have a gap because this histogram represents each frequency based on the ratio. Yeah, ratio means there's no gap between each number, right? But the bar chart, when you use a bar chart, we use a bar chart for nominal data or ordinal data, which means actually each item has a same value, right? So it doesn't have to be continuous value changes. That is just a discrete and has the same value. So when we use a bar chart, it always has some gaps, but when we use a histogram, then it doesn't have any gaps between each bins. There's a big difference. So yeah, keep in your mind. So, and then the bar graph, so we could say that is because it uses nominal or ordinal data, so nominal and ordinal data related to qualitative data set, right? So when we use a kind of a questionnaire, how much do you like this item? 0 is not so much, not at all, and then maybe 5 is very much. So this is just a qualitative data, right? Okay, let's keep talking about the standard and normal distribution. So this shape is a normal distribution, and then if we represent the normal distribution with a mean value of 0 and the standard deviation of 1, then we could say that it's a standard normal distribution. So in this case, this one, the red distribution, is a standard normal distribution, which is a theoretical distribution. So the interesting characteristic of the distribution is, as you see here, this left side occupied about 34%, and the right side also occupied with 34%. So the total is 68% of the observation in the distribution falls between the +1 and -1 of standard deviation from this mean. So and then if we see this side and this side and this side and this side, the area is getting narrows, right? So which means most of the data will locate within this area, right? And the standard deviation could have a different shape depend on the mean value and the sigma value, as you see here. And then the reason why I mentioned about the area is we could so we could say that the probability. What is the probability in this case? That is a little bit broad question, but I would want to say that is probability is a expected relative frequency of a particular outcomes, which is when we draw something, when we following some value around here, the probability is the probability of the value can be certain value around here has about 68% of a chance, right? So if we just want to know if some value located within this area, within this range, it has only 13.6% of the chance from the probability perspective. Am I correct?
You mean 13.6% probability?
13.6%.
Of the measure occurring once again.
Yes. So then what is the total of the probability from this distribution? What is that? That is always 100%, right? 1. Yeah. So which means if we sum every area, every number, then it will always be 100%, right? Then here is a short quiz. So from the normal curve, what is the probability of randomly choosing a score that falls above the mean? 50. Yeah. Here is the mean. Above mean is just represent all the area here. So that is a 50%, right? Good. So we could represent the distribution with this shape as well. So this is, I think this is a histogram, right? And the histogram, we could represent this histogram with this line. And sometimes maybe if we want to represent more details, then maybe we can reduce its bin size. But the other way is using the frequency polygons, which is just connect each, I think that was connect each median value. So just to connect everyone and then get some approximate frequency polygons. This is one of the way how we could represent our frequency with a probability distribution shape, this one. And then, as we mentioned just before here, I will not talk about deeply about what is a probability density function, which we sometimes call PDF. That is, we can calculate its probability by we calculate certain area. So this is our interesting area about its probability, right? So I just quickly remind you what is that. And the other way to represent descriptive statistics is dispersion. So how we can represent our data, which is using interquartile ranges. Is there anyone who used this type of representation before? Yeah, she did. And then somebody also, hopefully. So what is interquartile? Which means we can divide the data set with the four quarters. Quarter 1, 2, 3, and 4. And then interquartile range means that is simply just subtracted from the quarter 3 minus quarter 1. And then we just wanted to know these middle ranges because depends on the distribution theory, most of the data will be located in the middle. So hence we also want to have some interest in the middle data. So that is the reason why we're doing some interquartile ranges here. So this is the same things, and this is the median value. And then we could say, we say this is lower quarter, upper quarter.